In this tutorial, I will show you how to integrate or find the integrals or entire derivatives, it's the same, of algebraic expression. First of all, let's start with the basic case when you are given a polynomial, something like this. All you need to do is just remember the power rule for integration. So remember, differentiation actually reduces the power by 1. The integration raises, so increases the power by 1, since they are inverse operations of each other. Here's a power rule. All it says that the integral of a power of x to the n, with respect to x, is x to the n plus 1 over n plus 1 plus c, where c is a random arbitrary constant of integration, provided that n is not equal to -1. So in other words, all you want to do is just increase your power by 1, so your new power becomes n plus 1, and you want to divide your term by this new power. Now, another thing to keep in mind, that the integral of k, where k is any number, is kx plus c. Alright, let's get back to our integral. Since we are given a multiple terms being added and subtracted, all you want to do is just integrate each piece at a time. So let's start with the first one, which is x cubed. So by a power rule, we want to increase the power by 1, so it's 3 plus 1 over 3 plus 1. Now moving to the second term. So since you have a coefficient in front of x to the 4th, there is a special constant power rule that says that first thing to do is just keep these 2. And we're applying the power rule to the rest. So x to the 4 plus 1 over 4 plus 1. And moving to the last term, so the integral of 3, we want to just attach x. Don't forget to add arbitrary constant of integration c, since we end up getting a set of functions. Alright, technically we are done. All you want to do is just clean up this expression. So it becomes x to the 4th over 4 plus 2x to the 5th over 5 minus 3x plus c. So that's your general integral or just solution for this problem. As a quick side note, you can always check your answer. Recall that integration and differentiation, they are reverse operations of each other. So in order to do so, you want to take your answer and differentiate this. And what you will get, it has to be matched with the original expression that you are given. So let's do it quickly. So remember, we have to use derivatives rules now, so don't get confused. Actually, we are going to use only power rule for derivatives. Remember that the derivative of any constant c is 0, so c goes away. And as you can see, we will get precisely the same original integrand expression that we are given. So everything checks out. Alright, perfect. Let's move to another example. Say we need to integrate this. Looks intimidating. Anyway, remember, our goal is to use the power rule. So we want to fit everything into a power rule. So if you are not given powers at the beginning, we want to make them. So we want everything turn into the powers. So x squared appears to be in the bottom, and we want to bring it up by making the power negative. So use your basic algebra skills, power skills here. So for the second one, square root of x, we want to turn into a half power. And finally, for the last term, so your cube root of x simply means x to the 3rd power. And since it's in the bottom down, we want to bring it up by making the power negative. So you have to be very comfortable with these power rules for algebra. So we will get 2x to the -1/3 power. Alright, everything is written in terms of power. So now it's the high time to use the power rule. Let's begin. So for the first one, -2 plus 1, your new power. And we divide by this new power. Moving to the second one, so 1/2 plus 1, this is a new power. And finally, for the last one, we have to keep these two in front, first of all, and increase the power by 1. Alright, don't forget to add c at the very end. Now, let's clean it up. So for the first term, your bottom becomes -1, and x to the -1 power. Now let's proceed with this pesky fraction. So 1/2 plus 1, which is 2/2, is going to be 3/2. So your new power 3/2 over 3/2. And finally, for the last one, we are going to subtract actually a third from 1. So 1 is 3/3 minus 1/3. It's going to be 2/3. That's your new power for the last term. So 2/3, 2/3, and c at the end. Alright, keep simplifying. So actually we want to get back, we want to convert everything into radical form. And also rewrite your expression with positive powers. So for the next term, we want to keep 2, and when we divide by 2/3, it's going to be the same thing as multiply by 3/2, the flipped version. We can cancel 2. And we are going back to radicals and positive powers. For the first term, we've got minus -1 over x goes down. Now, for the second term, 2/3. And we are gonna have square root of x cubed. Remember, the bottom number takes a root, and the top number raises a variable to a power. And finally, for the last term, 2 goes away, so we are left with 3. And this fractional power, so cube root of x to the second power plus c. Looks legit. So that's your final integral.